So it's 11:30 now, and everyone's ready. One thing before I start talking, please turn off your cell phones, or at least put them in silent mode. It's really annoying when a telephone goes off during a presentation. I see everyone's shuffling around in their pants. Perfect. My name is Andreas Klein. I'll be your moderator today. I will host this track in the gallery, at least before lunch. And let's welcome Christophe Grand, our first speaker for today. He probably needs no introduction. He's written the book Programming Clojure, is an independent software consultant and a long-time Clojure enthusiast. I think everyone in the community at least should know him. He'll do a talk about pushing the REPL where no REPL has gone before. As you can see on the slides, we love the REPL. Yes, we all do. And let's give a warm welcoming applause to Christophe.
Thank you. So I guess that everyone loves the REPL. If you don't, maybe it should be better to go to the other talk. And I would say that we love the REPL so much that they have to try it from a cold dead end. We have to really cherish the REPL because it's something very valuable. And in recent times, I feel like it becomes more frequent than before that using the REPL is not doable or cumbersome or something that you don't do very often. So my own love affair with the REPL started right with Clojure. When I was learning Clojure, there was almost no tooling, so you just copy and paste it between the editor and the REPL itself. And even my first paid job, which involved Clojure, was related to the REPL. I had to write an extension for a PLM solution, that is a product lifecycle management. So it was a big J2E server, completely proprietary. And the official way to write an extension for this product was to first draw some UML diagrams, then annotate the diagrams, then run it through a pipeline to generate some Java code, which was going to be broken. So you had to fix the Java code, and hopefully you'll get something slow as hell that would maybe run in the product. And obviously, to do so, you had to go through 3 weeks of training by the vendor. And what we done is that we took the Hello World example from the documentation and changed it in a way that it would just start a REPL. Writing a bit of Clojure of Java just to be able to start a socket REPL, and then we loaded this Hello World extension in the product, and from there we connected the REPL and explored and live coded and experimented with the server. And so in the 3 weeks of training that should have been required to get started writing the application, we add it in production. So like I said before, I really fear for the REPL at the moment, because I think that there are many factors that are trying, or maybe not trying, but it's just that there are many factors that are setting up obstacles to the use of REPLs in our current environment. Well, the most common one is the good old edit, compile, run cycle, or the edit, deploy, edit package deploy cycle, anything which has a separate step of packaging is going to be a hurdle to use with the REPL. So most complex frameworks, you impose this kind of development. And there's also distributed systems where you have to package things so as to be able to distribute them amongst a cluster. And the distribution problem of the systems even becomes a problem for our development environment. Before, it was just a problem for staging or production environment, and most of the time you could get by with using the REPL in dev. But when your dev environment is made of several VMs or containers, and that you have to manage networking through them, or maybe use some other servers, it became less obvious how to use the JVM, because you have to do a lot of port mapping or tunneling to get to the actual process that you want to look at. But before looking a bit more in detail about these obstacles, I'd like to question you, what is a REPL? What is a REPL? If we try to qualify a REPL with what we do with the REPL, we are going to get many answers, and maybe not a comprehensive set of answers. To some people, a REPL will be a kind of playground where regularly they just start from scratch and start over. And for other people, it will be more like a notebook where they try step by step in a very conservative manner. For others, it's just a monitoring or debugging tool. Well, you have many, many use cases for REPL. But if you try to qualify what is a REPL from a technical point of view, it's very, very simple, because it's just that. A REPL is read, eval, print, loop. Really. This line, well, it's not loop, it's while true, but this line is a minimal REPL implementation in Clojure. And it's really just a REPL. The name REPL is its own source code. There's nothing more. So technically, it's very simple, and it's also very ancient. This computer is the first computer which ever ran Lisp. It was an IBM 704 with vacuum tubes, punch cards, and magnetic tapes, if you were lucky. And the original Lisp took 12 Ks of the 32 Ks of words of the memory. And you can see that it included reading and printing. And if you look further in the documentation of the original Lisp, you'll find the definition of read, which hasn't much changed in modern times. The read is just a function of no arguments, which returns the value which has been read, except that nowadays we read from a socket or standard input rather than reading from punch card, but that's the same thing. And print is also the same. Eval is a bit different. The E argument to eval is the expression to eval, and B, the bindings are the environment in which to eval the value. And then, in the last paragraph, it describes the go statement and how basically go to worked in the original Lisp. it's interesting to note that in the eval description, they say that the reader, and here by reader they mean the user should have no occasion to use this function. So we can conclude that eval was evil before goto was considered harmful. So the REPL is really part of the Lisp ADN, and it has been forever. Well, I have a pet peeve with Clojure script, especially with self-hosted Clojure script, because in self-hosted Clojure script, there's no reason that you can't have a real REPL, but we don't have one yet. Because if we go back, a REPL is read, eval, print, and loop. And in self-hosted Clojure script, there's no read. There's no standard input. There's no way to refer to the input in a stable way. You have to dig into the implementation of Lumo or Planck to be able to use that. And so for the read, eval, print, loop to work, you have to have a read which is blocking, because you want read to block until it is able to give a form to eval. And then you want eval to block until it has a return value to pass to print. And sadly, in self-host Clojure script, first we have no read, and then eval is not blocking. If because this is JavaScript, if you ever had to use a callback in the eval, you have no way to say wait for this callback to happen before considering the eval phase to be over. So the computation the print and the loop may happen immediately, while you'd like for the callback to happen first. And this is especially a problem because all I/O is callback based. So if you want to perform some I/O like reading, if we had a read, then you would also need a way to prevent eval from returning immediately. So since it's JavaScript, the obvious way is to put callbacks in read and put callbacks in eval. But it's not the least intrusive way to do so. I currently have a pull request pending for Lumo, which makes the Lumo a true REPL. First, it starts by exposing a read, an asynchronous read, which is going to take a callback, blah, blah, and eval. And eval is not going to be synchronous because not going to be really asynchronous because otherwise it would be too invasive in both the implementation of Lumo and Clojure script. Instead, in my proposal, eval either return an immediate value, meaning that, okay, the computation is done, you can print and go on, or it returns a suspension. It's more or less a special promise. And so when you get this kind of special promise out of eval, you know that eval is still doing some stuff and that you have to wait on the delivery of or the fulfillment of the promise to keep going. And so with this change, you can have a true REPL, a REPL where each component is exposed to the user, where the REPL is not a special loop in the interpreter, where it's just regular code. And it means that the user can recycle the REPL to do something else. For example, there's a recent project named Scope Capture, where you can record the scope during the invocation of a function, and then you can recreate a REPL at any point of the call stack during the previous invocation. And this is possible only because we have in userland all the pieces of the REPL. And it also matters because I'm developing a project named unREPL, and this project relies on the ability to change the REPL to something a bit different, so as to provide better tooling. And by the way, the idea of this project was born last year in the hallway discussion of clojureD. So, end of the rant on ClojureScript. For ClojureScript proper, the problem is a bit more difficult because there's the problem of the split brain between the JVM and the JS engine. So it's harder to solve. But for self-hosted, which runs in a single process, there's no reason for self-hosted ClojureScript to not have a proper REPL. And so back to the obstacles that I see against the REPL usage. First, there's the building. All these frameworks which require you to AOT your project before being able to use it. So you can't really test from the REPL. You can test some small pieces, but not the whole thing from the REPL. So you have to build, package, deploy, and so on. The solution would be to build and to deploy from the REPL, because if you think a bit more about it, all the work which is done by AOT, which is producing classes from source code, this is something that the REPL has already done, except that the classes are in memory, right, as opposed to being on disk. So there's no reason that we couldn't harness that fact and skip the AOT phase, just reuse what the REPL has, package from inside the REPL, and deploy all from inside the REPL. And the second obstacle was about using more resources than your own laptop when you have to deal with a cluster or big data, and that you are not going to crunch everything on your laptop. Then again, you need to distribute the computation. And so it's tied to the first obstacle, because you need to distribute the computation that you define in the REPL. But there's also the additional problem of broadcasting changes that you do at the REPL over and over and over. And by the way, there's a very interesting paper. It's an opinion paper. It's not a research paper, named Occupy the Cloud, which describes how to make distributed resources more accessible to end users. Because this is really related to having a REPL being able to use these resources. It's all about reducing the amount of distance between the code that you want to compute and all the steps that you need to perform to be able to get the result. And so about the first and second obstacle, in two projects in which I participated, we tried to address that. The first project was PodocEgg. PodocEgg is a library for Spark, Apache Spark, where you can just define any computation that you want over your datasets and have it run against the cluster from the REPL or not. You can obviously use the same thing from a regular program. If it works in the REPL, it will work outside, while the contrary is not true. And another project that I've worked on is Portkey. Portkey does about the same thing, but for lambdas, so that you can just at the REPL take a function and mount it somewhere in the API gateway or as an event handler for a message queue event or anything you want. Straight from the definition that you just wrote or sent to the REPL to the cloud, with no separate phase of deployment and building and so on. And the third obstacle, which is, I think, more often than not overlooked, is the fact that it's getting more and more complex to connect to the process that you want to play with, because you are not on the same network, so you have to use a tunnel, or maybe you have to set up several tunnels because you are more distant than that from the process. And all these are some steps that you have to take before being able to use the REPL. And all these small steps add some viscosity to the process of using the REPL. And a thing that I've been playing with for the last couple of weeks is the idea of writing a kind of library to bore tunnels automatically. So you can specify a connection string with all the steps, all the tunnel SSH or whatever. If you are using Kubernetes, you have to use their own kind of tunneling and so on. But anyway, the idea would be to have a connection string specifying the endpoint totally with all the steps required, and so that you can pass, instead of a simple network address, you pass the whole connection string, and the library establishes automatically all the tunneling for you. So this is something that I've been able to do for SSH. For other kind of tunneling, it's getting more tedious, because for SSH we've got some good client implementation of SSH existing. If we want to be able to tunnel through a pod in Kubernetes, for example, you have to implement from scratch their HTTP2, their tunneling over HTTP2, which is not really well documented. And so this is all kind of attempts that I've tried to push the REPL further. And I really think that you could too, and each time that you have to suffer of AOT, of cumbersome methods of connecting to an isolated process, you should think about how to make things easier. And some idea, if you want to explore, is that I really think that it's technically possible to have a REPL automatically opened when you hit a breakpoint, but really a real breakpoint, JVM breakpoint, even if it's in a Java class, that you can have REPL at breakpoint or at exceptions automatically, so that you can inspect the state of the application at the point of the error or the point of the breakpoint. This is something which was possible on the list machines. And I really think that it's possible using the JVM debugging infrastructure. But to do so, we have to stop thinking only about the Clojure level, and we have to try to cooperate with the host. And the host, JVM, has a lot to offer. When it comes to JS engines, there are less facilities, and when there are some, they are not very well documented. But for the JVM, at least, there are untapped resources for doing more dynamic stuff on the JVM with Clojure, and getting closer to what was done on the list machines. So that's all. Thanks.
Thank you, Christophe.
Thank you.
So you finished 5 minutes early, so we have a couple of minutes for questions. Any questions from the audience? Just raise your hand and I'll bring you a microphone.
Yeah.
Hello. Hi. You mentioned Kubernetes. Was that a coincidence, or did you actually have to implement the REPL connection through Kubernetes?
I don't have yet, but at work, my team is struggling with that because I'm currently working for a data science department, and so they are a part of the team which is made only of software engineers, but the majority is made of data scientists. And the mere fact of setting up tunnels is an hurdle for them. And so we are, yes, we are really looking on way to make their life easier, so that they can use Clojure more often than they use Python.
That sounds great, and please publish it somewhere so I can use it too. Thanks.
Right.
Any more questions?
Hello, so where can I find your SSH only REPL prototype, or is it non-plug? Is it private?
I should put it online in somewhere where it's not ephemeral, because I just published it on Slack for now, so maybe it's already gone. So I have to put it in minimal usable form, and I put it online.
All right, thanks.
Hello.
Hello.
Can you expand on the image-based REPL ideas you had?
Oh, yeah. So the traditional image-based development, for those who don't know, is the idea that you are constantly working on a live image that you can snapshot to disk and restore and so on. So there are several ways it could be done. Maybe the one very simple way to do that would be to just use Linux CRIU to snapshot the JVM, the whole process to disk and restore it. But there's another possibility, is that both in product keg and in portkey, we managed to not only package the definitions that have been done at the REPL, but we also package the state of some vars, and we serialize them and send them to the other end of the network. So building on this work, you could get closer to a real image-based experience.
So that's about it.
Okay.
How about some applause for him again?
Thank you.
Thank you.